All right, geometry. Chapter 8 is on right triangles, and 8.1 is on Pythagorean theorem and its converse. So this is like old news to you. We've been doing Pythagorean theorem all year long so far. It's very much related to the distance formula, okay? So here's your Pythagorean theorem, right? You know Pythagorean theorem in a right triangle, so it has to be a right triangle. You know that the sum of the squares of the legs is equal to the hypotenuse squared, right? Pythagorean theorem. So this guy is actually what it truly means. But for this picture, typically you remember it as a squared plus b squared equals c squared. Let's remember that c, the hypotenuse, is the longest side. So your hypotenuse equals the longest side. And again, if you remember from our chapter 5 talk, right, if this is a right triangle, the right angle must be the largest angle. And the longest side is always opposite the largest angle. Now, I want to do a proof of the Pythagorean theorem with you. There's so many proofs of the Pythagorean theorem, but this is one that I like to show just to signify that, it doesn't just come from anywhere. It comes from somewhere special. So what I have done is I've already created a square, I think. No, here. I think I did, right? No. It disappeared. All right, let me create a square real fast. Okay, so here's our square. You can see if I drag it or move it, it'll stay a square, okay? So here's what we're going to do. We're going to pick a point along the side and mark it. So I'm going to put a point right there. And I'm going to do it all the way around the figure. And to do that, I'm going to use the compass tool. So I'm going to measure this little length here, okay? And then I'm going to use the compass tool and this little length to make this circle and then to make this circle. And what that does is I know for a fact that it's going to give me this point, and I need one more. Sorry about that. Compass. And this point. Okay, so I'm going to hide those circles. And I'm going to connect the dots with a polygon. And hopefully you can see, or hopefully it looks like that I created another square. So what did I break this big square into? Well, I broke it into 4 congruent right triangles and 1 square. So here's what we're going to do, okay? So we're going to say that I broke each side into a length of A and B, A and B, A and B, A and B. And we're going to say that this square now has sides of length C. We're going to use area to prove the Pythagorean theorem. So what is the area of the big square? Well, the area of the big square is going to be A plus B. This side is A plus B, if I add the A and B together. And we're going to multiply it by this side, which is also A plus B. Well, this is a binomial times a binomial from your Algebra 1 days. You're going to distribute this or FOIL this. So the A is going to go to the A and the B. So A times A is A squared. A times B is AB. Then you'll do this B to the A and the B. Again, B times A is BA or AB. And B times B is B squared. And then this simplifies to A squared. The two ABs will combine to give you plus 2AB. And then B squared. So this is the area of the big square. Well, now we're going to find the area of the 4 right triangles and the smaller square. So I'll do that in, let's do a different color. Let's do it in red. So what is the area of the 4 triangles? Well, it's going to be 4 times 1/2. The base of each triangle can be B or A. It doesn't matter, so I'll do A. And then that means the height would then be B. It's just the legs of those two of those right triangles. And half of 4 is 2, so that's going to be 2AB. And then the area of the small square is just going to be C times C, which is C squared. And isn't it true that these two areas added together should equal that large area? Well, let's try that out. Let's add 2AB plus C squared. And let's see if it equals A squared plus 2AB plus B squared. Well, look what's on the same 2ab, 2ab, and look what I got. C squared equals a squared plus b squared. There's your Pythagorean theorem. Oh, that was bad. Just written backwards. Oh, sorry about that. You need to make it the circle a little bit bigger. And there you go. So there's a quick proof of the Pythagorean theorem, if you care. Okay. All right, very good. So let's go back to our notes and finish this section up. So again, the convert, I'm sorry, there are these things called Pythagorean triples. Now, Pythagorean triples must be non-zero whole numbers, A, B, and C. So can't be decimals, can't be square roots. That will satisfy Pythagorean theorem. Now, there are some common ones here below. 3, 4, 5 is very common. You'll use that a lot in pre-calc. 5, 12, 13, somewhat common. And now we're getting less common with 8, 15, 17, and 7, 24, 25. But these are the first 4 sets of Pythagorean triples. Now, you can create an infinite amount of Pythagorean triples by multiplying each number in the Pythagorean triple by the same whole number. So for example, if I were to multiply each of these by 2, I would get 6, 8, 10. That's another Pythagorean triple. If I multiplied by 3, I would get 9, 12, 15. Another Pythagorean triple. So there are infinitely many Pythagorean triples, but here are just a couple. All right, last but not least, the converse. So the converse is just the reverse of Pythagorean theorem. So it says that if you have 3 sides of a triangle that satisfy this theorem, then you know that that triangle is a right triangle. And again, make sure that the C is your longest side given. All right, so I got a couple delta math problems that I'd like to share with you on Pythagorean theorem. It'll be in the next video.